Hello, how's it going? Can you hear me? I can't hear myself. I'm kidding. Okay, so I see I have a full room. Let it go on the records. All right, so today I want to talk to you about building a robo-army with Angular. And like over the last couple of years, I've been playing with various devices, and I'll be showing you a couple of them. So my name is Sebastian Vitalec. I do a lot of Angular stuff, and I consider myself a master of robots. And if any of you is on Twitter, you can follow me. I am SebaVita. So let me start with the problem that I was trying to solve, right? So where I live, like I live in London, and there's loads of parks in there, and you have like all those squirrels everywhere, right? And squirrels are really nice and cute. You can go and feed them and stuff, and people just love squirrels. But the thing is, we all think that they're like these little great creatures, but are they really? So this is Jack. Jack started throwing peanuts at peanut allergic people, and they were swelling up and everything, and he got very aggressive. And then all the other squirrels started arming themselves. They started bringing bazookas, machine guns, and it's just like everything was going completely out of hand. Like we couldn't even go to that park. It was ridiculous. So basically, we called for help, and the stormtroopers arrived, right? And I was like, okay, we're gonna take care of it. Point some guns at them, like ambush them wherever they could. But that didn't last for long because basically they managed to strike back, and like the whole rebellion was just like going full scale. So we're thinking, it was like, okay, we can't just give away the park to the squirrels. So we called for help. And surprise, surprise, who answered? Our little robots. And the cool thing about robots is they don't really have lives, Like, if they die, they don't really care. You just have to replace their batteries. You can manufacture them. So they were very keen to help us. But the thing is that, like with anyone, like between people, the same thing with robots, we use different languages to communicate. And the thing is that with robots, we would have to use binary, right? So it's like, okay, so we have to find a way to communicate with those guys, okay? So one of the things we can use is Bluetooth. And the way Bluetooth works is actually quite simple. Like whenever you have a robot, you have functionality that is divided into a bunch of services, right? So you have a service for, let's say if it's a tank, right? You have a dashboard, a weapons service, and you have a drive control service. And then for each service, you have a bunch of characteristics. So characteristics is like more specific around what we're supposed to do with it. So for example, a dashboard will have like a speed indicator and a fuel indicator. Then we'll have different weapons like a acute ray and a laser ray. And then finally, for drive control, we have steering wheel, accelerator, and we have brake, right? So once you have the services and the characteristics, we can start thinking of communicating with those. And then another thing is that all those services will have their UUIDs, but as well, some services will be read-only, and other ones will be write-only. Some of them will be just there to provide notifications, et cetera, et cetera. So to construct a command, if let's say we wanted to reload our Qt ray, we would basically use the weapon service with a Qt ray characteristic, and we're supposed to pass in some values like, okay, so instruction will be maybe 0x2, 02, which will be for reload. Then we have how much we want to charge it and what sort of charge we want to give. And that basically usually kind of is combined in a command like this. So we basically provide all those parameters. And how we use that? So there's two approaches I want to talk to you about. So one is using web, and one is using mobile. Okay, so let's start with web. So in Chrome, we could use web Bluetooth, which basically automatically exposes all the functionality that we need. And the way we use it is very simple. Usually, we actually have to install the web Bluetooth, add some typings, and then in order to communicate with a device, you have to scan for it. Once you found it, you can connect to it. Then you get your services, you get your characteristics, and once you have the characteristics, you can start sending commands to it, either for reading or writing, okay? So let's go step by step. So first, to install, just npm install. To search for devices, we just called request device. And usually you can provide various filters or services. So for example, in filters, you would say, I want to only look for devices with name that begins with something, right? And also you could say, not only let's filter by names, but also I expect this device to contain this and this service, so that you can narrow down the devices that you're getting. Especially if you're somewhere where there's like 5,000 different Bluetooth devices, you don't want to be getting all of them. Like you want to filter down. So once we've done that, this will actually pop up a little kind of dialog in your browser, and then listing all the devices that are available. And then when you click on it to connect, basically this returns a promise. So we would get our device object. And then with the device object, what we can do is call connect. And basically, this will give us a server. And server is what has all the services, right? So with the server, I can, for example, call get primary service, provide a UID, and it will give me a service. If I need more than one, I just do it multiple times. And then once to get the characteristic, I basically use the service to get characteristic, and again, provide the UID for it. And then once I have that, I can basically either perform read commands. So I could, for example, use characteristic to read the value and then parse it. Or basically to send an instruction, I would use an int8 array and then pass in the parameters that we want to use. Right? So coming back to our rebellion, I've got this little guy that was like one of the first volunteers. And I was thinking like, OK, let me go and code it. The thing is that it wasn't as simple as that sometimes. Sometimes like those devices will have like quirky ways of communicating with them, okay? So one of the things is we would have multiple services to communicate with this guy. So we would have to use the UIDA, which has the command instructions and the flight parameters. Then we'll have another service, which basically is just to keep track of the status, how high are you, or like what sort of battery level you have, and what is the signal strength, etc., etc. So that's actually pretty obvious. You quite often would use multiple services. Another thing is, before you can even send a command to take off, or any commands, you have to kind of initialize these drones. So, and there's like few steps. So one of them is we have to keep track of the notifications. Even if you're not interested in the battery level, this drone expects you to listen, even if you ignore it, which is kind of weird. So basically what I had to do is get the primary service for it, then get the characteristic for that flight status, and just call start notifications and ignore that. Like actually in my demo app, I didn't want to know about the battery level. So that's first step. Another step is before we even take off, I had to set up the max altitude, max tilt, etc., these parameters, so that the drone kind of was ready to go, right? If I haven't done that and I told him to take off, the drone would just ignore me, which I found it a little bit weird. And then finally, for every command that I send, this kind of like, the whole thing is divided into sections where we have the prefix and the actual command message. And in this prefix, you see I'm using this step ++. So what happens is, because this drone expects me to fire a lot of commands into it, I have to basically say command number 1, number 2, number 3, number 4. That's what the step is for. So that it knows whether to ignore one or in which order to execute on that. So basically, if I wanted to call takeoff, I would basically set up my buffer with int8 array, and then pass in the step, which let's say is 1 first, and then send the right command, and then to tell it to land, I'll basically have to reuse the step again, and then this time pass the value 030 with the new step. So it's kind of like, it's a very clever thing, but if you didn't read the documentation, that wouldn't be initially intuitive, because some other devices, like for example this guy that I'll show you later, doesn't have this whole step thing. So luckily for you, if you want to use this drone, I actually wrapped it all in an Angular service. So you could just npm install it, and you'll be able to just call something like Mambo service search, and then once you get a device back, you have all sort of commands that you could call. So I kind of wrapped it up for you. So let me do a demo or show you the code itself. All right. Is that big enough? Perfect. I got a half from the first row. Amazing. OK, so this is where my Mambo service comes in. So I'm using dependency injection to add it here, and then I'm calling Mambo search, and then basically that will call the pop-up where I can look for my device. And then inside, if I go, I have this where the Mambo service implements that. That's exactly when I'm calling my navigator Bluetooth request device. So that's one of the first steps of the commands. So this is how we do the search. I'm going to get a device. And then once that's done, I'm creating my special drone object, right? So the drone object basically wraps up the functionality like takeoff, land, etc. But it also has the code to connect to the server, so it connects to the device, and as well does the initialization. So this is where here I'm constructing all the characteristics and then setting up all the flight details. So for example, you see I'm using two different primary services, and then I'm setting up a bunch of characteristics that I'll be using to communicate with the drone. And then just for the stepper, I actually created this drone characteristic object, which basically keeps track of my steps. So I have this private underscore step, and then every time I call next step, it will basically help me construct the command so that I don't have to keep track of it. So basically, a write instruction is basically saying, hey, let's prepare the buffer. So it will do 2, get the step, provide 2, and then params is the values I'm passing in. So this will prepare a buffer for me, and then basically just call characteristic write value. So coming back to drone, using those characteristics, for example, to land, I can call flight command instruction, write without response, and I can pass 030 or 010. And that basically constructs the whole command. All right, so let me go back to the actual application. So in here, I already exposed functions like takeoff and land, but I also have like loads of key listeners. So if I press A, D, W, like the drone will be moving all around. So let's do the actual demo part. Let's see. Oh yeah, it would help if I actually run the application. So yeah, and yeah, also the drone can run at like different speeds. So I will set it up at 50% because there's not that much space. All right, so let's search. So you see, it brings up the pop-up, finds my drone, should connect, and it will take a little while, ready to fly. And for example, I can press takeoff, and I can fly the guy. All right, let's go. Faster. Anyone feeling warm? Oops. Oops. No. Go back. Come here. I'm feeling warm. And like after a bit of practice, I can even make it land on like a very small space. So this floor is pretty small. Let's land it there. Hey, I managed. For a moment, I was doubting whether I could actually get the floor or not, but hey, I managed. So let's go back to the presentation. So that's the first of the guys that joined me to fight the rebellion. But what if you want to go beyond Chrome, right? This is where NativeScript comes in. So if you use NativeScript Angular, and actually you don't even need to use Angular, but this is in the context of Angular itself, we have this NativeScript Bluetooth plugin. And in case you don't know about NativeScript, it's basically an open source framework that allows you to build mobile applications for iOS and Android, and you can use JavaScript or Angular or Vue, which is worth knowing. So all of that I'm showing you, you can actually use free and open source and contribute to it. So how do we do this with NativeScript Bluetooth? So what we have to do is add the NativeScript Bluetooth plugin. Then we probably have to request permissions if you run these applications for the first time on your device. Then again, we do scan, we call connect. However, we don't have to actually call get characteristics or get services. That basically comes with every command that when we call read and write. Okay? So this is how we do it. So to install plugin in NativeScript, which we just call TNS plugin add, give it a name. Then we have to require the NativeScript Bluetooth. And to request the permission, and this is literally, you only have to call it once in the lifetime of this application, right? So the first time you run it. So when we call request calls location permissions, there'll be a pop-up on your phone asking like, hey, this device trying to access this sort of parameters. Are you okay with that or not? And if the user says yes, then we're ready to go. The next thing is to find a device we call the start scanning function. And then basically, we say how long we want to search for it, but as well on discovered is for every device that we see in the area, basically this callback will return. So using this peripheral, we can get things like the UUID of the device and the name of the device. Okay, so you can basically display to the user so that you can do something with it. And the next thing is connecting the device. So once we know which device we want to connect, we just call connect, which is a massive surprise. We pass it the UUID, and then we have two functions. On connected, so basically when you call connect, it will take like a few seconds until the device is actually ready. So this is basically a callback when the whole thing is ready, and then we're ready to send commands. So this is one, and then the second function we have is on disconnected. So if for some reason the device disconnected, then you get again a callback and you can deal with it. So you can maybe try to reconnect or basically tell the user, go and pick up your drone somewhere in the forest. I don't know where it is, but it's disconnected. And then finally, to read basically values, we just call Bluetooth.read. And in here we provide the UID of the device, the service UID, and characteristic UID. So every time you want to read, you pass these parameters. And then basically this will return a callback with your data, which you can parse, and then, for example, read the battery level or whatever you need. And then to write is very similar. Again, so we can, for example, construct these write options. Again, UID of the device, service UID, and characteristic, but then also you can pass a value. And this value could be a string, or it could be an array, it could be int8 array, whichever you prefer to use. And then basically you take these parameters and you call write without response, pass in the options, and basically that should be going. So another hero joins our fight with the rebellion. So that's General Mipush. I can start him. Actually put him on the floor. Quiet. He's a bit excited. So basically, controlling him is a lot easier, so I'm not going to go through like challenges and stuff. But I also created a library for NativeScript. So if you use NativeScript, you can just install it called NativeScript Meep BLE, which wraps up all the functionality for you. So as soon as you connect it, you can call like Meep move or Meep turn left, etc., etc. So I'm going to show you a small demo then. And this time, I'm going to do a bit of coding to show you how it works. So, TNS run Android. I'm going to build the application. So my demo app already has like the whole UI constructed. I just have to fill in the gaps. So I have my function for scan and function for connect, and then I'll be going step by step. So to connect, I just call Bluetooth. Or actually not. I'm not connecting, just scanning. And this is why I love TypeScript, because I don't have to remember what parameters are there. So I can say, okay, scan it for 3 seconds, and then on discovered, we're gonna get a device. And then I have this devices array here, so I'm just gonna push it in there, each of those. So a device will have a name, so that's device.name, and also a new UUID. So again, device.uuid. That's one thing. Oh, I'm actually gonna add a small if in case there's devices with no names. I can just ignore it. So let's do it this way. Yeah, I'm getting to you. Seriously. Robots these days, they don't behave. We're a spoiled robot. All right, let me show you. Okay, so this is actually my phone. So you see, when I'm scanning, it actually finds like a bunch of different devices. Actually, even sees the drone, but MIPU is one of them. Okay, so if I basically click on this, you call this connect function and then pass in the UID of this device. Okay, so let's implement that. So quiet. Seriously, I'm working here. Okay, so let's connect. And then this time we need to pass in the UID, which I have just above. We have on connected. So that gives us a device. And stop it. Right. That will teach you. So on connected, what I want to do is navigate to another page. So I have this navigate function. And I have to just pass in the UID for it. And then finally, I'm going to do on disconnected. So in this case, I'm just going to throw an alert that will just say disconnected. All right, let's save that. So the app should refresh. Here we go. So now again, I have to scan, press on me push, and he should turn green in a second. And then we move to the next screen. So on this screen, we have buttons like move forward, move back, turn left, turn right. So how are we going to implement them? So luckily, the guys from Huawei that created the drone, the robot, they provided us with documentation. So if I, for example, pass in 0x71, and then a value between 0 and 30, and then 0 and 25, we'll be able to move to drive the robot forward. So let's do that. So if I go to the controller, I have my move forward function. And this time I'm going to call Bluetooth, write without response. And I need to pass in all those parameters. So let's start with peripheral UID. So this will be my device UID here. Then we have service UID, which is FFE5. That's something you can check in documentation. But that's very common. This is one of the most standard addresses, FFE5 and FFE9. Almost every Bluetooth device uses that. So we have those parameters, and now we have to just provide a value. So value is where we provide the parameters. So let's add int 8 array. So in here, I was saying, let's do 0x71. Actually, I don't really need to copy and paste that. And then value between 0 and 30 for speed. OK, maximum speed. And then for how long? Well, as long as it gets. So that's how we drive forward. And basically, to drive backwards is the same, except I'm doing 0x72. So let me copy that so we can move him back and forth and save that. Right, you ready for demo, Archie? Let's see. He's excited for it. All right. So let's scan, connect. So every time we refresh the application, we lose the connection, but that's OK. And now I can move forward. That's not very fast. And move back. Maybe I should change his batteries. He's been on the road with me for a little while. So that's the first part of the demo. And then basically, we can implement like turn left, turn right. So that's 0x73. And again, we can change the angle and the speed. So I'm going to implement that very quickly. So turn angle is 0 to 255. So let's put like 90. I don't think it's really in degrees. And a speed of 25. Well, 24 is the maximum. So that's for turning left, I think. And that's going to be turn right. Let's refresh that. He should refresh anytime now. He gets always excited when he gets disconnected. He's got like this free roam mode, so he can walk by himself all around. But I never let him to do it for too long, because then he talks. and that's annoying. All right, so now I can make him turn around one way or another, move back, move forward. The thing is that with this command, I can either tell him to turn or move. I can't make him like move and turn at the same time because those are like very basic commands. But we also have this other function which is called continuous drive. And this one basically allows me to pass in parameters to turn and move at the same time. So I can tell him how fast he can go forward or backwards and then how much he should be turning either direction. And basically, I'm meant to send this command every 50 milliseconds so that it, like, continuously you have to keep telling him what he has to do. So I already have this implemented. So I have this, I'm using accelerometer. So I'm going to show you that. And then basically, as I'll be tilting my phone, I'll be updating, like depending on X and Y position of my phone, the turn and the speed so that I could move him. So I can use this one. And now I can kind of move him around. I don't think he likes carpets. Trust me, he goes really fast at home. And then it's literally just me tilting the phone and making him move. What about the other function? No. Yeah. So that's pretty much that's the whole trick. So now we have Mipush who can join us in a fight with the evil squirrels, right? Right. Come here, Mipush. I will need this guy too. How cool is that, huh? Nobody impressed? Come on! Live coding, everything, entertaining. You guys are a hard crowd. Oh, you want some shooting? Okay, all right. He asked for it, right? Remember. Okay, he wanted shooting. That's it. So, this guy actually has a cannon. So my drone has a cannon, and since you were speaking out, you'll be my volunteer in a moment. Have you ever done any acting in your life? Yeah, like no, acting like an actor, you know, like Schwarzenegger or something, you know. You get shot, you fall down, then you stand up. No? Okay, there you go. Perfect. So, this drone has a cannon, okay, that can shoot and stuff. And then when I went to the documentation of the developers that created it, I couldn't figure out how to use it because the commands were all messed up, right? Like I lost half of my hair trying to make it take off, and then I just didn't want to give up the rest of it just for the cannon. So I was thinking like, okay, but the drone comes with its own application, right? So you can install it on Android or iOS, and we can do stuff with that, right? So if you're using an Android device and you enable Bluetooth HCI Snoop lock, and then start the application, start using it, then when you close the app, basically you get this file, which is BTS Snoop, which has all the logging information about the movements, all the commands that you sent. So all I had to do is just basically take that file, drop it in a Wireshark, and then try to figure out where is the command I'm after. Okay? So, you know, we can find like all the service UIDs, we can find the values for each command. So I think, you know, we can kind of do it. So I created a bunch of test instructions. So I started the application, called fire a couple of times. I made the drone take off land, fire a few times again, take off and land. And then since we already know take off and land was like 010 or 030, I could just basically look for that command. So let me show you that in action. Try to make it bigger. So what really happens is, like I already more or less know where it is, so I sorted all the commands based on the characteristic UID, and then I was able to look for my whatever command, and then there's like 000100 030. So that's one takeoff and land, then 3 other commands, and then again takeoff and land. So basically the command I'm after is what's here. So I can basically see, okay, so this is my 04, the step value 02, and everything from then on is my actual command. So let me go back to presentation. I can take it step by step what I was doing with it. So finding those values, I was able then to isolate this and then kind of say, okay, this is the exact command I need to use. So basically, the actual values will be 10, 02, and a lot of zeros. And then in my code, I was able to add the fire function. So with doing that, now I can basically call write without response, pass all those values, and then we're ready to go. So since you said you're going to be my volunteer, I wasn't kidding. You want to do it? Come on, round of applause. Come on, come over, come over. So when you get shot, you have to fall down. Like, go far, make it a challenge. Make it a challenge. Just stand over there. All right. So I'm going to start again the drone. It's going to shoot you for real. Seriously. You've been my like 6th victim. I don't know how people still fall for it. It's incredible. Take off. So you were asking. Don't worry, it's not going to hurt. You're going to die instantly. Why not? Oh wait, the cannon is detached a little bit. I need to reconnect it. All right, that was intentional. That was intentional. All right, let's see. No, it actually has real bullets, man. They explode on contact. All right, it works. Let me take over again. All right, let's see if I can get him from far. Left. Oh, got him! You see? He's a sniper. You have to fall down. You have to fall down. When you get hit, you have to fall down. Again. Fall down! Oh, he's not going to fall down. What kind of actor are you? Kamikaze! All right, thank you. Good job. I mean, he's like a superhero. Like, he's definitely like Schwarzenegger. So many bullets hit him and he didn't fall. Wow, I'm impressed. Well, I'm not, but I am. So the thing is, with the drones and the robots, we're able to put a good fight. And the outcome of the whole fight was the unconditional surrender of all the squirrels. So it's like now it's pretty safe to go back to London, you know, go to the parks and have fun and enjoy yourself. They're not going to bite you. They're not going to attack you. Jack doesn't have peanuts anymore, which is good. He actually went to like a special place where I put a sweater and he was hugging himself, you know. He was a bit weird. So the summary. Playing with Bluetooth is actually quite fun and it's quite easy, like I was showing you. I was pretty much able to control the robot like in less than 5 minutes. There's a bunch of examples that you can use from the services I created. So if you look at any of those 3, so the Mambo Angular service is just for the web. The other 2 for the Mambo and the Meep, they're just for NativeScript. So you can go and check the code. Also, there's kind of like there's some differences that is worth knowing. So if you use the Bluetooth plugin for either Android or iOS, you can actually connect up to 10 devices. When it comes to web Bluetooth, you can use it on Chrome, Mac, Windows, on Android. So it's actually supported quite widely, but you can only connect to 1 device at a time, right? So if you want to build an army and then control like 10 robots at the same time, you have to have a mobile application. And I have like generals. Yeah, actually, I have like 8 of them at home, and sometimes when I'm, you know, when I had a beer or something, I actually connect to all of them and I make them dance. It's hilarious. And then there's another version of the web Bluetooth. If you're into observables, you can use the plugin from Wasim. It's pretty cool. So rather than getting promises back, you can get observables, so then you can cancel the instruction, etc., or retry if, let's say, the connection failed. which happens sometimes. And then finally, you can do some reverse engineering. So if you use HCI Snoop and Wireshark, and you already have an existing application, you can go and figure out how to do it. Right? Let's say you already have a mobile app, but you want to build a web application to do it. Right? And sometimes the documentation is not perfect. There's some other things, like you can use some pattern matching tools if you want to start snooping in there. And then at one point, I actually started building a replay tool that you can drop the whole snoop log and then make it like go step by step by step, so you can see which exactly instruction is working. Because if you don't have a single instruction as a reference, it is actually pretty hard. So that's pretty much me. Thanks for having me, and if you have any questions, yeah, you can clap now. Yay! How are they on time? Any questions? There you go.
That restriction on the one web Bluetooth connection, is that just per browser window?
Yeah, we per browser.
10 browser windows.
Yes, you can, yeah. So, yeah, it's just the library, and I know the guys that are working on it, they're working on extending it, but for now it's a little bit hacked inside. In terms of responsiveness, like web Bluetooth is really fast, so that's a really good thing as well. So you can rely on it, even go to war. Yeah. What's the range? So that's web Bluetooth, which is low energy. So with this drone, I took it to a park, and I was able to fly like 50 meters away from me and like 10 meters high, and I had no problems. I was flying over the trees and everything. So on open space, it's pretty good. If you're indoors, I think you can even try to go through 2 walls if they're not too thick. Just like your Bluetooth headphones, right? It's a similar thing. All right, I don't see any more questions. Thank you for oh, there. So my drone is a Mambo. What's the company? Parrot Mambo, yeah. They're actually pretty cool. They're like 100 euros, so they're not too bad. And there's now a new one which has a camera, so you can have like a Google VR, and then connect your phone, and you can control it, which is pretty cool. All right, thank you for your time.